vertex form looks like this. There's actually a couple different ways that you might see it written. This is the first one. This is one way you'll see it. Sometimes you see it where the K is on the other side. Okay? This is not the method the book uses. All right? At least I don't think so.
Should we still write it down?
It's up to you. I'm just telling you that you might see it this way. If you see it this way, you can just move your K over. Just add K to both sides, and when you move it over, you get this one here. Right? So they really are saying exactly the same thing. They just might look different when you first glance at it. Okay?
The book won't be like that.
I don't think the book will be like this. I'm pretty sure it's like this. Okay? I mean, the one they gave you is like that, but I'm not saying that every problem within the book looks like that. Okay? So, what's important out of this is that HK is the vertex. All right? HK is the vertex. Y equals 8x squared is the parent function. Okay? That's the parent function. Who in this room, whose group worked on quadratics? I think there's a couple of you. At least one of your groups worked on quadratics. Was that your group, Alyssa?
Mm-mm.
Oh. Yeah, they're up there. One of you put a poster up there. Noah and Benny, what do you think? Was it you? You didn't do that one with a highlighter on it? Or you did the rational one? Okay. Sorry. Alright, so, well, somebody here did. You must have forgotten what you were working on. But anyway, you worked on quadratics, and we discovered that y equals ax squared is the parent function. So if I took this example, y equals 2x squared, and I wanted to graph that, I could make a table real quick, okay? Because there's no x and no c, its vertex is going to be at the origin. Because 2 is positive, it's going to open up. And so if I just pick a couple, we'll go 3, -1, 0, and 1. And so if I plug -1 in, square it, times 2, I get 2. If I put 0 in, square it, times 2, I get 0. If I put 1 in, square it, times 2, I get 2. Right? So my graph looks like this. And so I have 0, 1, 1, and -1, 1. And so my graph looks like that. Okay? Now, if I take this equation, y equals 2, x minus 3 squared plus 1, okay? What does that mean the vertex is going to be? Where's the vertex going to be in that over there? What do you think? Vertex. I'm hearing -3, 1. Alyssa's shaking her head. She's not sure what to think. 1, -3, I'm hearing. What's h represent? The x of the vertex, right? What's k represent? The y of the vertex. In the formula up there, what does it say in front of h?
Positive 3.
It says minus h, right? So when I go look at this, this says minus 3. So what's h?
Positive 3.
Positive 3. It's a positive 3. The formula has a minus here. So whatever that number is going to be h. Okay? If it has a minus. So this says minus 3, so this is h. And then it says plus k. So it's plus k, so what do we have here as a k value? 1. So if I move this up so I can graph that now, I'll change colors. We'll go 3, 1, 2, 3, 1 up. So there's my graph, or there's the vertex of my graph. Okay? Now the nice thing about this is, the rest of the graph is determined by this number right here, which is exactly the same as this number right here. That means the rest of the graph is exactly the same. Okay? It's exactly the same. The 2 identifies the steepness, or should I say the narrowness or the wideness of the graph. Whether it's going to be real fat or really skinny. Okay? It's determined by that number in front of the x squared, which is the a value, which is that number in front of the parentheses right here. Sorry, right there. Okay? It's that number there is what determines that. So that's why this is a parent function. Right here, it's a parent function because that determines the look of the graph. Opening up has a skinniness of 2. It's not really the proper way to say that, but there really is no proper way to say that, so we'll try to say it in a way that I hope you're understanding. If it was a 10, then that would make these numbers all 10 times as big, wouldn't it? I should say 5 times as big, because it's already times 2, right? So it would be 5 times bigger than what's already here. If it was a 1/5, then that would take, well, not these numbers, because they were multiplied by 2. But we'd have to just take all of whatever this is and multiply it by 1/5, or in other words, divide it by 5. Okay? So that's going to make it really wide. That'd make it a graph look like this. Okay? That looks like a smiley face. Do that. All right. So, to find the vertex, we simply look at h and k, and it looks backwards, because whatever h is in the equation, the opposite of that will be the vertex value. Whatever k is in the equation is exactly what it will be in the vertex. Let's throw a couple more examples up here. So we just identify the vertex, okay? So if I have y equals negative 3x plus 1 plus 3. So what's my vertex in this case? Negative 1, 3. That's correct. The opposite of this, and whatever that is. Okay? So if I have y equals x minus 1 minus 4, what's my vertex now?
1 -4.
Louder, please. I couldn't hear you.
1 -4.
1 negative 4. Okay? Am I going too fast for anybody? Anybody confused on when I'm switching and when I'm not? So if they give you an equation, they ask you to identify the vertex, and the equation's in vertex form, you simply look at those two numbers and then realize the h is always the opposite. I should say the x is always the opposite of whatever that h is there. And the k is the y is whatever the k value is. Okay? Alright. Can I turn to the next page?
Yes.
Alright? So if I give you a graph like this, let's actually do this so that we can get a nice looking graph. if I apply these points right here, oh, come on. Try it again. And so I get something looks like this. Okay. And they asked me to identify the vertex of that. Write it in vertex form. Okay. Let's first of all identify the vertex. So what's that going to be?
6, 4.
What is it?
6, 4.
6, 4. Okay. So over 6 and then up 4. So my vertex is 6, 4. I agree with that. And so y equals x minus h squared plus k. So right now we know y equals, don't know a yet, but I know h, and it's x minus 6 squared plus 4. Now what if I was over here? Then it would be minus a negative 6, right? So it would be x minus a negative 6 if the point was right here. And so that would become x plus 6, right? So make sure you realize that. All right, so now I'm missing my a value, aren't I? Okay, so the easiest way to find your a value is to pick another point. Pick another point on that graph.
4, 0.
4, 0. Okay, good. 4, 0. Doesn't matter which one. So x is 4, y is 0. So we say 0 equals a, x was 4, minus 6 squared plus 4. Right? What's 4 minus 6? My negative 2. And if I square that, what do I get? 4. So I get a times 4 plus 4 equals 0. Okay? And so if I subtract 4 from both sides, I'm going to write a times 4 as 4a. Does that make more sense? What do I do now? Divide by 4. So what's a equal to? Negative 1. So I go right back up here, and I put my negative 1 in. And now I just found the equation for that graph. Okay? I just found the equation for that graph. All I needed was a vertex and then another point. I use the vertex to plug them in for h and k. Then I pick another point for x and y and solve for a. Okay? Should I look at one more of those? You guys seem to look a little more puzzled on that one. Yes or no? I don't want to waste your time. If you got this, we'll move on. Give me a show of hands. Everybody respond. Up you're good. Down you need to see another one.
We see another one.
Okay. All right. So again, let's pick another graph. Let's make this one move up, and we'll put it down here so we let's move it to here. Okay. Oops, here. And I want to go here and here. Here and here. So my graph looks something like this. Not perfect, it's kind of peeling away here. Something more like that. Okay? So my graph looks like that, and they want us to write the equation for that graph in vertex form. So again, someone tell me what is the model for vertex form?
Y equals A. X minus H squared plus K.
Okay? And so what's the first thing I can put in?
Vertex.
The vertex. So what goes in for H?
4. Negative 4.
-4. What goes in for K?
Negative 5.
So we found the vertex is -4, -5. So if I plug those in, I get y equals, I don't know A yet, x minus a -4 plus -5. Right? And some of you are realizing, well, minus a negative is a positive, and that's good. Others, maybe you need to write it this way. That's up to you. I'm going to rewrite it. Still looking for A, but x plus 4 minus 5. Okay? So now, what do I need to find A? What's that? Pick one then, Dewey. -2, 3. Okay? This one right here. -2, 3. So y is 3. A, we'll put a variable in there now. X was -2. Okay? I don't know why I started right 10. But anyway. So I get 3 equals A. What's -2 plus 4?
2.
2, and 2 squared is 4, minus 5. So if I add 5 to both sides, I get 8. And A times 4 is 4A. And so A is equal to 2. So there's my vertex form of the equation that represents that graph. Okay? Got that written down, Aslan? Now, what time is it?
Almost quarter after.
Okay, so we pause this for a second.